Welcome to Building Connections, presented by IPEX. Each week, we delve into the world of construction, exploring how key leaders in the space shape the infrastructures of tomorrow. Discover the stories behind the solutions that impact municipal, commercial, and residential projects across North America.
During this interview, Mark Bruder speaks in his personal capacity. While his views may align with his work at RVA, they do not represent the company's formal position.
Welcome to the IPEX Building Connections podcast, where we explore the world of infrastructure, innovation, and the unseen forces that keep our modern lives moving. I'm your host, Greg Blackett, and today we're diving deep, literally into one of the most high-profile, high-risk challenges in engineering, and that's structures and tunnels. Joining us today is Mark Bruder of RVA. RVA is an engineering firm, and Mark works there and specializes in high-profile, high-risk civil projects, particularly in the sustainable infrastructure areas, and we are super excited to have Mark on. Welcome, Mark. Welcome to the IPEX Building Connections podcast, where we explore the world of infrastructure, innovation, and the unseen forces that keep our modern lives moving. I'm your host, Greg Blackett, and today we are diving deep, literally deep, into one of the most high-profile, high-risk challenges in engineering, and that's around structures and tunnels. Unlike above-ground construction, where problems are visible and often manageable, tunnel projects operate in an environment of complete uncertainty, and they're hidden behind layers of earth and rock. So if you think about a single mistake underground, like hitting a water pocket or weak soil, that can trigger a catastrophic event, such as flooding, collapse, or equipment failure. And the stakes are really high. And so really what lies beneath the surface? Joining us today is Mark Bruder of RVA. RVA is an engineering firm, and Mark specializes in high-profile, high-risk civil projects, particularly in the sustainable infrastructure. And we are really excited to have Mark on. Mark, welcome.
Thanks, Greg. Happy to be here.
Excellent. So Mark, you're an engineer, and I am fascinated to hear the stories of how people got into engineering. And I thought, before we go into some of the cool projects you're working on, what sparked your passion for engineering, and where did you go to school, and how did you get into the business?
I was fortunate enough when I was young to go to Canada's Wonderland and Cedar Point and Disney parks in Florida. And that really kickstarted my interest in roller coasters very early in life. And I knew that I wanted to design them or somehow have a part of them, but I didn't really know how. And when I was young in school and then later in high school, it turns out that I accelerated in math and science. And one day my guidance counselor said, maybe you should go into engineering. And that's all it took. It was just as simple as that. I went to Western University in London, Ontario, and my very first class in the very first year was something called statics. That's how to understand things that have forces on them, right? And that steered me to structural engineering. And from there, that's how I got into it.
Very cool. And it's interesting. You're saying to me, and I think we're sharing an interest, a common interest, which is roller coasters. And so that's something that sparked your interest. So I understand that you've got a background in roller coaster design. Is that true?
Yeah, I actually worked at Cedar Point 1 year between, I think, my second and third year university. And the goal was just to get exposure to them at a different level than being a guest in the park. I wanted to be around them more frequently. Now, I got hired in the food service division, not the ride maintenance division, but I was fortunate enough when I was there to be on a committee where different people from different departments got to meet with all the VPs every few weeks to talk about issues. And that's when I met someone named Monty Jasper. He's an elder statesman in the world of roller coasters and theme parks. And it just so turns out, again, a bunch of lucky circumstances, that when I interviewed at RVA, the chief structural engineer, Tom Richardson, knew Monty. So I had a story, he had a story, they knew each other. And from there, again, I realized, wait a second, Tom, you've done work in roller coasters? I didn't even know this going into it. And he said, yeah, I've designed almost half the stuff at Wonderland, the foundation, some of the buildings. And wow, from there, I knew this was where I had to work. And I started doing little things like retaining walls and foundations for little Ferris wheels and stuff. And that ballooned into working on the tallest, fastest ride in Canada.
Was it the Leviathan? Is that the one?
Leviathan. That's right.
So it's funny because we're talking, the theme of this podcast was underground. Well, we're starting off on the above ground roller coaster. Maybe just how did you go from these complicated rides, the largest roller coaster in Canada, to okay, you're going to switch gears and move over into high stakes civil projects. What'd that transition look like for you?
Yeah. So the interesting thing about working in civil and structural engineering, and certainly where I am at RVA, is you're always doing lots of different things at the same time. So we don't specialize in one thing. We do lots of different things. So throughout my career, I was working on water, wastewater, infrastructure and tunnels and specialty structures. So I had lots of experience in below ground tanks that are buried or open, tunnels, all the way up to complex structural steel. So it wasn't as much a focus on one thing and then pivot later. It was just doing a whole bunch of everything. And when the opportunities arose to work on a big project and we were asked to work on it, then I jumped and I said, hey, I need to be a part of this somehow. And, to be clear, there are specialty firms that design roller coasters all day long. That's all they do. Basically, from the ground up is them. And often what will happen is a consulting firm will get brought in to design the foundations, make sure it doesn't move, make sure it's stable. Sometimes we design the structural steel all the way up to the rails. Sometimes there's a bit of a blurring of the lines. It's not obvious what we're going to do. But for Leviathan, it was mainly foundations. And that's what I had experience in at the time.
Okay, got it. That's such a cool story, and it's a well-known roller coaster, so to have your name associated, that's really cool. So I want to switch gears. Mark, you've been with our RVA for a while. You've worked on a whole wide range of projects. A lot of these are high profile, high risk projects. And I want to get into it a little bit in terms of it, we talk a lot about projects above ground, and I think there's this whole world underground that's interesting. And a lot of us that aren't involved in engineering and planning things underground aren't really aware what lies beneath. Maybe walk us through what is underground, maybe in a project that you worked on. It's not visible. So how is it different to plan and work underground versus maybe above ground?
That's a really good question. And it's really important because a lot of construction claims and issues that arise are often due to things that happen underground. And that's because you could drill hundreds of boreholes along a 10-kilometer tunnel, but you're only capturing less than 1% of the actual material that's there when you bore through it with your tunnel boring machine. And you have to make assumptions and inferences between the boreholes, what's happening. You have to take all the data and bring it to a lab and do tests, but taking it to a lab doesn't necessarily reflect how it's going to behave in the real world based on the kinds of construction means and methods you're going to use. So one example of this would be the Coxwell bypass tunnel in Toronto. It's a 10.5 kilometer tunnel that goes from Ashbridges Bay. It does a big circle all the way up to Coxwell Ravine Park. It's a 6.3 meter inner diameter tunnel. It's 50 meters deep. It's primarily through bedrock, but there are hidden valleys, soft ground valleys that it passed through. It went actually across the Don River and ran up the Don River parallel to it. And wouldn't you know, rivers are not straight. They go like this. So the risks of hitting soft pockets, hitting water, not being in rock with the right amount of cover above you such that you can, maintain stability. Those are the kinds of challenges. So what you end up doing is spending lots of time and money, warranted, doing a very thorough as you can, geotechnical investigation program. You look at the soil, the rock, you look at the hydrogeological conditions, and you try to put together what we call a geotechnical baseline report. And that's something that is used by contractors and owners to put lines in the sand. So there are very specific tools that we use in tunnels, in tunnel construction, shaft construction, to make sure that we quantify it as best as we can. We manage the risks as best as we can with historic knowledge, with project-specific geotech investigation. And typically that works pretty well, but there's always unknowns that can't be quantified. And that's what engineers try to manage during the conceptual design, the pre-design, and the detailed design, and through construction with monitoring and all those kinds of things.
Yeah, it's fascinating. And I imagine every project is so unique and different. There's likely a lot of hidden risks that you only uncover maybe when you start digging. Can you share any examples where project you've worked on has resulted in something unique, unplanned for, and you had to maybe make a change in the process, or you discovered something that underground that you didn't plan for?
Sure. So specifically on the Coxwell bypass tunnel, there are 5 shafts. They're each in the order of 20-meter diameter by 50 meters deep. And one of those shafts, which is next to the viaduct in the Bloor Danforth, the bridge, that shaft had a big fault going through it, right? And the problem with that is you can do a borehole right in the middle of it and you wouldn't necessarily see it because it was on a slant and it was at an angle that the borehole didn't find it. And you wouldn't have known that was there unless you peppered the entire site with a bunch of very deep boreholes. And sometimes when you encounter joints like that, they have water that are trapped in them and wants to come through them. And, you have to make sure that when you're putting all your temporary works up there, your rock bolts, your welded wire mesh, whatever it is that you're using, that you have to recognize as you're digging. If conditions are changing, you have to make sure that you recognize it as changing, notify the owner, notify the engineers, and as you proceed, just modify your means and methods accordingly. It doesn't necessarily mean there's going to be a problem. Sometimes it's a schedule impact. Sometimes it's a cost impact. Sometimes it might be a safety impact if you don't recognize that conditions have changed. But the important thing is that conditions will change. We can't quantify the ground perfectly. There's no way. The only way to quantify the ground perfectly on a tunnel is to bore the tunnel. And that's what you do. But you have to understand what's there before you start so you can price it, get the risks associated in the right places. So that's not a catastrophic example. It's just an example of no matter how much geotech you do, and you should do as much as you can, I recommend, you're never going to find everything perfectly. So that's why owners have to be realistic and understand that you can't eliminate all risk. All you can do is work towards mitigating some of it in a way that you understand, that the contractors understand, that you priced into your contingencies properly, and just move forward together during construction, recognizing that this is one team. We got to be safe. We got to get it done. Let's just work together to solve the problem. That's the way that these usually are successful when you encounter changes in conditions.
Yeah, that makes sense. And I think every project is so unique. There's got to be recognition that nobody really knows underneath what until you start digging. You also, Mark, work on projects that you call sustainable infrastructure. And I'm really curious about that. What do you mean, or what does RVA mean about sustainable infrastructure? And maybe you can talk about a project that is a sustainable project that you've been involved in.
Sure. Sustainability is a big term and people use the word sustainable and green and it's lofty. But at the end of the day, what we're really trying to do is understand what the specific project is all about, make sure we're doing the right project, and then we make sure we do it in the right way. Is this the right project for this client in this place at this time? And are we doing it the right way? We got to evaluate the environmental impacts from a life cycle assessment. It might cost more now, but in the long term, it will cost much less, right? We got to look at the carbon footprint, resource and energy efficiencies of whatever we're doing. We like to prioritize local sourcing of materials and kind of comply with the local policies and regulations instead of grabbing stuff from across the sea if we don't have to. That costs more greenhouse gas emissions. We try to choose materials that have recycled content and don't have toxicity. Maybe consider renewable materials like wood, which isn't often possible in certain types of things we do, like water, wastewater. You're not going to build a tank that holds sewage out of wood. And then the most important is collaborating with stakeholders, making sure they understand what they're getting into. Sometimes doing things sustainably is more cost effective. You're just doing the right thing at the right time. But sometimes there's an initial capital investment beyond what the normal way is. And that has to be something they're willing to put the time and effort into, getting engineers to take the time to understand, how do we make this more sustainable? And if there is a premium cost, what are those impacts over the life cycle? And are you willing to accept those? So an example of one of those projects that I'm working on right now, it's currently under construction in Toronto, is the Wastewater Energy Transfer Project at Toronto Western Hospital. This is for UHN. And this is with the company Noventa. They're the Noventa Energy Partners. They're the owner and operator. The contractor is Bird Construction. RVA has a big role. We're designing top to bottom the wet well shaft and the tunnel that crosses the street to get to the energy transfer station. This project is all about supplying clean green energy to the hospital, 1.8 billion kilowatt hours over 30 years. And that actually reduces 90% of the hospital's space heating and cooling. It's about reducing your CO2 emissions by 250,000 tons, saving a whole bunch of electricity, saving some natural gas. And what this project does is it taps into one of the biggest, most challenging deep rock sewers in the city, and it temporarily transfers all of that sewage into a wet well shaft. It extracts the solids and returns them back. And then it takes that wastewater that's been screened and it does energy transfer. Sometimes it takes the heat out. Sometimes it rejects heat into it based on whether it's winter or summer. And the important thing is that this sewage is there. It's flowing. That heat is a resource. That sewage is a resource that isn't really tapped. So if we can take the heat out, and it's always going to be there at generally consistent temperature, if we can reject heat into it, then the environmental impact is your sewage is a little bit hotter or a little bit colder than it would normally be. But we're gaining all of that energy for a hospital or a university or whoever the client is. And this technology is used all over the place in Europe. It's not as much used in Canada, but that's changing. And one of the important things about the City of Toronto is they recognize that this is a new technology that uses a resource that it's their sewage, so they can leverage that. But also it is cleaner and greener. And the more we can do it, the more the cost will come down, the more clients will want to get on board. You don't necessarily have to be a hospital. You don't have to be a university. You don't have to be a huge client to leverage this heat in the sewage. So that's what we're trying to do now is show this as a bit of a case study that works, do more and more projects. We have a whole bunch of projects going on in the city at the moment under design. Some are moving towards construction. And we really hope that this helps the public recognize that it's not double, triple, quadruple the cost to get these projects done a bit more efficiently with sustainable practices, and everybody will benefit in the end. Because if we don't take the time to do these types of projects now, then it's going to be a little bit harder later when we need to meet different higher targets.
Yeah, correct.
Yeah.
And so really cool project that you just highlighted. I'm curious, did the hospital identify the goal of saving the sustainability goals, or what drove the project? Or was it you guys that said, hey, there's this technology available? Oftentimes when we talk about sustainability, I would imagine your clients would need to identify their goals first, and then you build around that. Is that what happened in this project?
Yeah, there's a bunch of factors where, so talking about the owner, Noventa, they are the exclusive distributors of what's called Huber Therm-Wind system. That's the system that uses the heat exchangers and the screens to make all this happen. They're the exclusive distributor in North America. And what they're doing is bringing it here. They're putting together business cases where they identify sewers and locations where there's a large amount of flow, hundreds of liters per second of sewage. And what they'll do is they'll work out, okay, what are the demands of this hospital or this university? What are the demands for heating and cooling? What can we gain from this sewer? And then they put together a business case, and they'll go to the hospital or whoever and say, hey, look, we know that you have climate GHG reduction targets, because most clients who do that publish it. They publish it and they say, hey, we're trying to be clean and green. And what they'll do is they'll start conversations with the stakeholders and say, look, we might be able to help you reduce your costs. We might be able to help replace some of your energy with this type of energy, which reduces your CO2 emissions. And after the client has a look at the business case, they'll sign an MOU, and then we're off to the races. We're starting detailed design. RVA gets involved at various stages. We might be doing the detail design, the construction support. We might help with the business case. There are other consulting engineers who are involved at different times for different things. So ultimately, it's a development partnership where we are a bunch of consulting engineers who like to work together to help do this type of work. And so there's probably 10 projects ongoing right now in Toronto, and they're looking to expand elsewhere. So it's not obvious who to target next sometimes, because as clients get more and more aware of this technology, they might come to Noventa instead of Noventa going to them. So what I'm hoping to do at RVA, I'm on a few committees for sustainable infrastructure. And what I'm hoping to do is just help find who these municipalities and clients are and start telling them this is a type of technology that exists that might benefit you in a bunch of ways.
That's great, because I was wondering if it was a technology that only worked in a very large scale projects, but it seems like there's enough of them and enough of the opportunities out there to really scale this. So that's really good to hear. I was taking notes before when you were talking about life cycle assessment on choosing relative building materials into your projects. So can you talk to us a little bit more about what that is, life cycle assessment? And do you require those from all of your, when you make choices around building materials?
So an example would be in London, Ontario, we did a job for the city. They have some reservoirs called the Springbank reservoirs, and they needed to replace the roofing membrane because they're buried tanks at grade and there's soccer field on top of it, right? And that membrane is at the end of its life. They last about 25 to 30 years. It's made of HDPE. So when we won the job and we started working on it, we evaluated lots of different types of materials that could replace that membrane, that waterproofing membrane. And we ended up not replacing it with HDPE. We replaced it with a topping, like a big, heavy concrete shower cap. And we embedded in the concrete a whole bunch of slag, which is a material that normally isn't used, but it has beneficial properties to concrete. And instead of going to a landfill, it goes into the concrete, which is one of the sustainable practices that we try to do. And when we presented to the city using a more expensive option, they were a little bit, why are you presenting this as one of the options? Let's just slap another HDPE on top. But we showed them the life cycle assessment instead of having to rip it off again in 30 years, disrupt the community, kick up a bunch of dust. Now you don't have a soccer field again for a few years. This concrete option, it has a life cycle of 60 plus years. You won't have to touch it again for this type of issue. And after that many years, you're only doing the project once. You're not doing it again. So it does in fact cost less over, say, 60, 75 years. So if they're willing to put up the money earlier, if they have the money in their budget, then they'll save money in the long term. Plus, we're using materials that aren't as impactful and we're impacting the public less. So there's just a variety of ways to think about using sustainable practices and materials that it might not be obvious at the beginning when you start a project, but these are some of the discussions that need to be had and some of the analysis to just help our clients understand the benefits of potentially spending more because the life cycle assessment shows that it's less overall. It's sometimes a hard thing to stomach because maybe the money's not there
Yeah.
right now.
But I think what really underscores the reality of of a material in terms of its actual greenhouse gas contribution, its actual impact on the environment, because it's more of a methodical science-based approach that looks at it from cradle to grave. And so you can actually look at the data and say, look, this is actually a better option for you. Maybe it's more expensive, but like you say, you're not going to switch it out over every whatever 20 years. So that's good. And we had interesting you said about recycled materials. We had a guest on earlier that actually pointed out to us that sometimes recycled materials isn't the best way to go because you're forcing a recyclate into a material can create more of an environmental impact. So again, if you look at the life cycle analysis, it should reveal the reality of if recycle is good or bad. So it's important to look at those as the source of the truth. That's good. The other question I had for you, Mark, is around sort of safety and in terms of your firm, how you approach safety on a job. We talked about tunnels before. I would imagine a lot of the projects you work on are high risk in terms of worker safety, equipment failure. What's the approach to your own team safety, the culture there, and how you protect other workers on any given job?
That's a good question. And it's really important. From the design side, as an engineer from the design side, safety of the public is paramount. It's the number one most important thing. So whenever we design stuff, we design it in its permanent state, but we also have to consider how the contractor is likely to build it with their temporary works, their chosen means and methods. And sometimes that actually informs how we design the permanent works. So for tunnels, for example, there's lots of types of methodologies. There's one pass through rock or two pass. There's soft ground tunnels, rock tunnels, there's drill and blast. There's lots of different types. Part of thinking about safety from the very beginning is not just what's the permanent works going to look like and how does the client want to use those permanent work, but how are they likely to build it? And then once it transitions into the actual construction phase, nobody goes to site from RVA unless they have full safety training from the many types of trainings that we do. That includes just the general understanding of trenching and being aware on site, all the way to confined space, understanding what is a confined space. It's not obvious sometimes. Confined space is not just a tiny manhole. It's a specific type of definition. And the important thing is that if anything looks unsafe or feels unsafe, or if anyone is asking anyone to do anything unsafe, people have the right to refuse without any reprisal whatsoever. And we don't tell people when they go to site, climb that 50-foot tall ladder and look at something. We don't tell them to do things that are unsafe. But there are activities that the contractor might be undertaking, just inherent in those activities they are risky. And that doesn't mean that the contractor shouldn't be doing them. It just happens to be risky when you're in a tunnel riding on a little train cart, zooming past things. You just need to be aware of your surroundings, make sure that you have all of your safety equipment on, make sure that you're communicating actively to everyone around you at all times, making sure they're seeing you when you're walking behind a truck, making sure that there are safety protocols in place, that the contractor has made a plan, posted the plan, is adhering to the plan. We have our own plan. So everyone is responsible for safety in their own way. And we all have to be aware of that. And every time we hear an accident about someone getting hurt, doesn't matter who or where, any job, anyone who's an engineer and a construction worker, we feel it, because they sometimes happen randomly. Sometimes they're freak accidents. Sometimes something just went wrong, and we all really feel it. I'd say the culture of trying to be safe on most jobs, it's pretty strong. And it really is. People want to work safe, go home safe.
No, that's exactly the right attitude. And it's paramount, and it drives everything that at least we do here as well. And Mark, I wanted to give you the opportunity to maybe talk about anything that was on your mind. But before we do that, if you look into the future, any city of Toronto or wherever city you know best, how do you think these projects change over time? What does a city look in the future in terms of some of the big engineering projects? Is it more changes to transportation? Is it more water, sustainable infrastructure? What types of projects are going to be more important or more prevalent in the future?
That's a really good question. It really depends on the specific needs of that city. So Toronto has lots of gridlock all the time. They're currently working on rehabilitating the Gardner, which is an elevated expressway. And throughout the time that this has been worked on, traffic's been a little bit worse. So I would suggest that Toronto is working pretty hard these days to remove friction to get around the city, whether you're in a car, whether you're underground in a tunnel. There's lots of subways being designed and built right now. I would suggest that those are marquee projects, the stuff that people aren't always aware of that are going on in the background, but have multi-billion-dollar investments, are things like what I spoke about earlier, the Coxwell bypass tunnel. That's one stage of a 5-stage, $4 billion project that aims to help manage combined sewer overflows or just stormwater management. And there are something like 25 kilometers of tunnels, a whole bunch of storage tanks. And it's not obvious that the city is spending time and money designing and building those things. All people tend to see when there's a massive flood is, oh, the Don Valley Parkway is flooded again. I can't drive my car down to get to work or whatever. And that's a huge impact, and it legitimately is. But these things do take time to design and build, and it's based on capital availability. It's based on doing all the background and information gathering, geotechnical. So cities, and I'm not a city planner, but cities tend to spend the money on both the marquee stuff to provide immediate relief and benefits, but also a huge amount of background infrastructure that isn't seen, isn't really known about until they're providing immediate benefit. And that can be sometimes decades away. And that can be a little bit of a hard pill to swallow when people have more immediate needs, but we have to invest all that money, not just in the new stuff, but in maintaining the existing stuff. Sometimes you have pipelines and they might be at the 50-year life cycle, and at 60, they need to be replaced. And if you don't start thinking about rehabilitating it or replacing it or twinning it or whatever you have to do, if you don't start thinking about that until it's falling apart, it will be more costly to do something about it, because that infrastructure might not be available when you're trying to fix it. So this long-term planning, it has to address so many types of things. And that's one of the challenges of working at a big city, like even a small city, because a small city might not have the tax dollars to do that kind of huge project. They might only have one big project per year, and it might not be the one that everybody immediately feels they need. So it's very tricky. And on the consulting engineering side, we're trying to forecast as well to better understand what projects are coming, so we can certainly align ourselves with our team and our partners to be ready to help bid on that project. But we don't have the crystal balls either. So we try our best to project and predict and talk to the PMs, our clients, and understand what's coming. But it's a struggle. it's definitely difficult to do.
It is. Yeah. And you only can plan what you have visibility for. And there's also projects take longer and sometimes the funding mechanisms takes a while to actually get allocated to projects, which slows things down. How about stormwater? Do you see a growing emphasis on the need for cities to invest in stormwater infrastructure and versus sending it into the local waterways?
Yeah. So one of the challenges with that is historically, stormwater that ran off the roads went to the sewers. And the sewers aren't really supposed to be treating that kind of water because sometimes they can get completely overloaded. And what we're seeing a lot of cities are doing is separating those. You have your sanitary and you have your stormwater. They're separate pipes for separate directions doing separate things. You don't want to have your overflow into the lake with all the sewage that is now combined with all the stormwater happening multiple times a year. You really do want to separate that. And the fact that we're seeing more intense rainstorms more frequently, you might be getting a 1 in 100-year storm more often than 1 in 100 years. So it's more important than ever to make sure that whatever infrastructure you have below the ground, which again is not visible, it's designed or at least upgraded or rehabilitated, maintained to manage those kinds of increased storm events. And we've seen lots of cities separating their storms and their sanitaries. And Toronto just embarking on this big one, the Coxwell bypass, as part of the Don River and Central Waterfront projects, right? Again, this is a multi-decade, multi-billion-dollar level project. And again, it's not always obvious how to sell that to the public, except where their basements are being flooded or their highways are being flooded. I'd suggest bigger cities have a easier way of managing it, whereas smaller cities have to come up with maybe different, unique solutions.
That's a good summary as well. Mark, this has been really insightful and I really appreciate you coming on. Anything else that you wanted to cover on your end, or is there something we haven't talked about?
I happen to be involved in the Canadian National Steel Bridge Competition. It's run by the CSCE, and it has students from universities all across Canada and internationally compete. And I'm really passionate about it. It's part of the mentoring and what I do for the juniors here too at RVA. And it's happening in Winnipeg this year in 2025. So I just wanted to highlight that if anybody does want to get involved in this kind of engineering where you design and build a scale model bridge 20 feet long, I think it's really important for engineers who are in university and even younger to see that you can really run a real project from beginning to end where you're building something tangible, you're competing against others in a timed way, you're loading the bridge fully. It's really valuable to undertake those kinds of experiences before you get into, quote, the real world, where you recognize that you've learned maybe 5% of what you might be using on a daily basis. Maybe you haven't learned what you're doing immediately the day you arrive at your next job. And I think these kinds of projects, it just gets people started thinking about these things. And I think it's really valuable. I didn't do any of that stuff when I was in university, and I kind of regret not having those opportunities and undertaking it. So I'd really recommend students look into it if they're listening. It's the Canadian National Steel Bridge Competition, and hopefully they can get involved.
That's great. And so I guess we'll have to circle back and figure out the winner or how the competition worked out in Winnipeg. So maybe we'll have back for that. Thank you very much, Mark. This has been great.
Thank you. Take care.
Thanks for tuning in to this episode of Building Connections. You can find links to all of the resources mentioned in today's episode in the show notes. If you're finding value in our podcast, please take a moment to subscribe and leave us a 5-star review. It really helps us connect with more listeners like you. Don't miss out on future episodes. Keep listening and building connections with us.